Learn about vector embeddings, which transform rich, data-like words or images into numerical vectors that capture their essence. This course from Anya Kubo will help you understand the significance of text embeddings, showcase their diverse applications, guide you through generating your own with OpenAI, and even delve into integrating vectors with databases. By the end, you'll be equipped to build an AI assistant using these powerful representations. So, let's begin.
Hi everyone, and welcome to this course all about vector embeddings. By the end of this course, you'll be able to understand what vector embeddings are, how they are generated, as well as understand why we even care about them in the first place. We're going to do this thanks to visual explainers, as well as some hands-on experience by building out a project that uses vector embeddings to cement your understanding of them by the end. My name is Anya Kubo, and I'm a software developer and course creator on YouTube, as well as on codewithanya.com. And I'm going to be your guide to this hot but slightly complex topic. So before we get going, let's just have a quick look at what this course will cover. So first off, we're going to learn what vector embeddings are in the first place and what they're used for. After we understand that, I will show you what a real vector embedding looks like and show you how to make one yourself. And after that, I will delve into why companies might want to store vector embeddings in a database, as well as show you how to store vector embeddings in your own database, just as a company focused on AI would. Next, we will take a quick look at a popular package called LangChain that will help us with the next part of making an AI assistant in Python. And if you don't know any Python, don't worry, I'm going to talk you through it step by step. Okay, so a lot to learn, but by the end, you should be an expert in this aspect of AI development. So what are we waiting for? Let's do it. What are vector embeddings? In computer science, particularly in the realm of machine learning and natural language processing, or NLP for short, vector embedding is a popular technique to represent information in a format that can be easily processed by algorithms, especially deep learning models. This information can be text, pictures, video, and audio, and much more. Let's look at text embeddings first. So in terms of text, we can create a text embedding that will give us more information about a word, such as its meaning, that a computer can understand. A word will go from looking like this for us humans to this for computers. So essentially the word food is represented by an array of lots and lots of numbers. But why do this? Well, think about it this way. Say we have this text right here. Daria went to town on foot. She set off early in the morning to beat the rush to the shop. She wanted to be sure to get the best lettuce and tomatoes for her grandfather's recipe. Now, say you want a computer to scan this for words with the closest meaning. If you ask a computer to come back with a word similar to food, for example, you wouldn't really expect it to come back with lettuce or tomatoes, right? That's what a human might do when thinking of similar words to food. A computer is much more likely to look at the words in the text lexicographically, kind of like when you scroll through a dictionary, and come back with foot, for example. This is kind of useless to us. We want to capture a word's semantic meaning, so the meaning behind the word. Text embeddings essentially represent that, thanks to the data captured in this super long array. By creating a text embedding of each word, I can now find words that are similar to food in a large corpus of text by comparing text embedding to text embedding and returning the most similar ones. So words such as lettuce instead of foot will be more similar. Now, you might still be wondering, what even are these numbers? What does each one represent? Well, that actually depends on the machine learning model that generated them. To understand how these numbers can help us find words that are similar, however, let's look at this fantastic visual explainer from Jay Alamar. I absolutely love this explainer, so full credit to him for these next few illustrations. It really is great. Imagine you are asked to conduct a personality test, similar to that of the Big 5 personality traits test that rates your openness, agreeableness, conscientiousness, negative emotionality, and extroversion. The test requires a score from 0 to 100 on each of the 5 traits in order to get a good understanding of a person's personality. Let's start by looking at the extroversion trait first. Imagine Jay gives himself a 38 out of 100 as his introversion-extroversion score. Let's show this in one dimension, like so on the left. Now let's switch this out to be a score of -1 to 1. Now, it is hard to know a person from just one personality trait, right? So let's add another one, and in turn, another dimension. the agreeableness score of a person, for example, or any of the other 5 traits. Great! And already you can start to get a better understanding of Jay's personality. Now, say we have 3 people. Here are their personalities plotted out based on 2 personality traits. So we can see them on a 2-dimensional graph, and we can also see them on the right in numeric representations from -1 to 1. Now, say Jay got hit by a bus, and we miss our friend and want to replace him with a person with a similar personality. Dark, I know, but you get the idea. When dealing with these numerical values or vectors, a common way to calculate a similarity score is using cosine similarity. This is the formula for getting cosine similarity. Using cosine similarity, you will see person 1 is more similar in personality to Jay than person 2. But still, 2 personality traits probably aren't enough. Let's use all 5 trait scores so we can use 5 dimensions for our comparison. Now, the problem is this is kind of hard to draw, let alone think about on a graph. This is a common challenge in machine learning where we often have to think in higher dimensional space. However, cosine similarity still works so we can get a numerical value by passing through the vectors for each person we want to compare to each other into the formula to get one numeric value which represents similarity. So now, by comparing J to person 1, J to person 2, and J to person 3, we can see which person is most similar to him. Great! Now that we understand this concept, let's look at the actual text embedding. So, for example, this is the word food generated by OpenAI's Create embedding. So, as you can see, it's an array of lots and lots of numbers from -1 to 1. The meaning behind each numeric representation varies based on which model generated them. Here are some of the other models you can use to create text embeddings. So we've got OpenAI, as we've seen, Watervec, and Glove. So, as we now know, we can use these text embeddings to compare them to other text embeddings, just like we did with the example of comparing personality trait to personality trait. Apart from, instead of capturing a personality, the meaning of a word is captured instead. There is another cool benefit to turning words into numeric representation. One of them being that we can now apply math to them. Take, for instance, this now well-renowned example. So king minus man plus woman equals queen. So for example here, you can see how you can take the word king and minus the word man and replace it with the word woman, and you get queen. This is truly incredible, and it's all thanks to text embeddings. We can use code in order to pass through the words king and woman and subtract man, and then we get a bunch of words returned to us, each with a similarity score. Queen is the most similar, and hence it has the highest score. Pretty cool, right? Let's move on by actually talking about what vector embeddings can be used for. So far, we have looked at text embeddings, but vector embeddings actually cover a lot more. Text is just one of the things that we can vectorize. We can vectorize sentences, documents, nodes and graphs, images, and even our faces. We have word embeddings like we just seen. This is one of the most popular applications. Word embeddings like Watervec or Glove convert words into dense vectors where semantically similar words are closer in the vector space. For instance, just so we saw, king and queen would have vectors that are closer than king and paper. Next, we also have document and sentence embeddings. Methods like doc2vec, BERT, and sentence-BERT can represent whole documents or sentences as vectors. This can be used in document classification, semantic search, and more. Next, we also have graph embeddings. Nodes in a graph can be represented as vectors. Applications include recommendation systems, social network analysis, and more. Here are some of the primary applications of vector embeddings. We have recommendation systems. Embeddings can be used to represent users and items like movies, books, or products. The similarity between user and item embeddings can help in making personalized recommendations. We also have anomaly detection. If you can represent data as vectors, you can measure instances or similarities to detect outliers or anomalies in data. We also have transfer learning. Pre-trained embeddings, especially in the context of deep learning models, can be transferred to another task to kickstart learning, especially when the target task has limited data. And also, amazingly, we have visualizations. High-dimensional data can be converted into 2D or 3D embeddings using techniques like TSNE or PCA to visualize clusters or relationships in the data. We also use it for information retrieval. By embedding both queries and documents in a shared space, one can find documents that semantically match the query, even if they don't share exact keywords. And of course, we can use them for natural language processing tasks. Tasks like text classification, sentiment analysis, named entity recognition, and machine translation benefit from embeddings as they capture semantic information and relationship between words. We also have audio and speech processing. Audio clips can be converted to embeddings for tasks like speaker identification, speech recognition, or emotion detection. And finally, we can use it for facial recognition. Face embeddings can represent a face as a vector, making it easier to compare faces and recognize identities. So a lot of things that vector embeddings can be used for. We're going to create a few of our own in the lesson coming up, but the main takeaway here is that the core advantage of vector embeddings is that they provide a way to transform complex, multidimensional, and often discrete data into a lower dimensional, continuous space that captures semantic or structural relationships within the original data. Next up, how do we generate vector embeddings? I'm going to show you how using OpenAI's Create Embedding. Okay, so here we are on OpenAI, so please go ahead and log in or sign up if you haven't before, and you'll be taken to this landing page. Now, once here, what we are going to do is interact with the API. So just go ahead and click that. And the first thing you will need to do is just make sure you have an API key. So under your username here, just view your API keys and go ahead and create a new secret key. I'm going to call this demo key like so. So that is the name of my key, and I'm going to create a secret key and save this somewhere safe. So please go ahead and do the same, just save your API key, and once you're done with that, click done. You can, of course, delete previous API keys to revoke access to them. So that's what I'm going to be doing with this one so that you can't use it in the future. It will be deleted. Now, once you have that, let's go back to our API reference. And what we're going to do is create embeddings. So let's click on embeddings here. Here's the URL. If you are lost, just copy that into your browser. And we are going to be using the embedding object. So essentially, here is the code that we're going to use. So it's right here. We have it in Node.js. You can have it in Python, or you can also have it in Hual. It is up to you, whichever one you would prefer to do. So let's just go ahead and use this version first. So this is what we're going to be using. This is the request we're going to write. And this is the response that we are going to get based on the input we passed through. Okay, so essentially the food was delicious and the waiter ... is now represented by this embedding, this array of numbers right here. So let's go ahead and do it. I'm going to copy this, just make sure that is copied. Let's get up our terminals. I'm just going to make this a little bit bigger for you. Let's paste that in. And now here we need to replace the OpenAI API key with our own. So let's just go ahead and do that. I'm just going to navigate to that piece of text, delete it all, just like so, and paste it. And let's just use the same input for now. So hit enter, and amazing. So there is the array of essentially numbers from -1 to 1 that make up the food was delicious and the waiter ... So there we go. There is that whole object, the full thing right here. It is also telling us how many tokens we have used in order to create that. So great. I'm just going to clear that out. So let's paste that in again. In fact, what we can do is just press up. And now let's change the input to something else. So for example, let's just use an example from the beginning of this tutorial. Let's just go with food. So food, hit enter, and that is the text embedding for food. Okay, it's this whole array, and we have used exactly 1 token to create that. Amazing. Now it's time to look at vectors and databases. With the rapid adoption of AI and the innovation that is happening around large language models, we need, at the center of it all, the ability to take large amounts of data, contextualize it, process it, and enable it to be searched with meaning. Generative AI processes and applications that are being built to natively incorporate generative AI functionality all rely on the ability to access vector embeddings, a data type that provides the semantics necessary for AI to have a similar long-term memory processing to what we have, allowing it to draw on and recall information for complex task execution. As we now know, vector embeddings are the data representation that AI models, such as large language models, use and generate to make complex decisions. Like memories in the human brain, there is complexity, dimension, pattern, and relationships that all need to be stored and represented as part of the underlying structures, which make all of this difficult to manage. That is why, for AI workloads, we need a purpose-built database, or brain, designed for highly scalable access and specifically built for storing and accessing these vector embeddings. Vector databases like DataStax's AstroDB, built on Apache Cassandra, are designed to provide optimized storage and data access capabilities specifically for embeddings. Now that we understand how important it is to store these vectors in the right type of database, let's get to setting one up ourselves in preparation for creating our AI assistant. So let's do it. So first off, I'm just going to navigate to DataStax and log in. Please go ahead and sign up if you haven't already. This is what your screen should look like once you are signed in, and you can see all your options here as well, along with your username and so on. So as you will see, I've previously created a bunch of databases on here already, but don't worry, I'm going to show you how to get started completely from scratch. So all you're going to do is click Create Database here and make sure you have Vector Database selected. And once you have that, it's super simple. Just go ahead and name your database, making sure to use the correct characters. So for example, it won't let you use certain ones. You have to use ones that are allowed. You will get a little prompt message if you do use an incorrect one. I'm just going to go ahead and call my database Vector Database. Now, we have to create a key space name that will go inside our database. And once again, just make sure to name it with the correct conventions. So I'm just going to call it search, as that was what we are creating. We are creating a vector search database. So I'm just being super literal with my naming conventions. And now I'm going to pick a region that is closest to me. So I'm going to go ahead and select US East 1 and then just click Create Database. And that's it. That's really all that is. You will see my database is pending right here. We have done it. We created our database. I'm going to leave that running and come back to it when it's time to use it. And pending has gone from pending to active. For now, let's carry on with a little bit of learning. Before we dive into creating an AI project, I want to talk to you a little bit about LangChain. LangChain is an open source framework that allows AI developers to have better interactions with several large language models, or LLMs, like OpenAI's GPT-4, for example. We can use it in Python or JavaScript, which is great news for us developers. What do I mean by better interactions, however? Well, for one, it allows developers to create chains, which are logical links between one or more LLM. You can even use it to load documents such as PDFs or CSVs, for example, to chain to each other or an LLM. Heck, you can even use it to split up documents and much more. You can have basic chains or more advanced chains. We will be creating our own chain soon enough in this course. For now, just know that LangChain's superpower lies in allowing you, the developer, to chain together different AI large language models, external data, and prompts in a structured way in order to create cool and powerful AI applications, such as an AI assistant, for example, that not only uses data from the internet, but perhaps an essay that you wrote as well, that we can then feed into it in order for the AI assistant to answer questions about it too. Okay, so we finally gathered enough knowledge in order to proceed in building an AI assistant built in Python. So let's go ahead and do it. Just to recap, this AI assistant is going to essentially be an AI assistant that will help us search for similar text in a data set. Okay, so once again, we are going to be able to get some data, break it up into little chunks, save it in a database in order for us to essentially perform vector search on it, thanks to packages such as LangChain. Don't worry if that's a lot. I'm going to be explaining everything step by step as we do it. So first off, let's go back to our database in order to continue with this tutorial. So we've already created a serverless database. The next thing we're going to do is actually learn to connect with it from an external source. And in order to do that, we need to essentially get our token. So please go ahead and get that token. We need to go to the Connect tab, and we're simply going to get an application token using the Generate Token button in the Quick Start section. So you can save this in any way you want. Just make sure it's saved somewhere safe. Now, once we have got that token safe, we need to get a secure connect bundle. Okay, so just go ahead and do that, get your bundle, and once again, save this somewhere safe. This time, however, we're going to download the secure bundle because we're going to point to this somewhere on our computer. So just download the whole thing onto your computer, into your downloads, wherever you want. Great. Now that we have that, once again, we are going to have to get our API key. So as a refresher, all you're going to do is head over to the OpenAI.com page. And then once you have signed in, you will see this platform and you're going to go to API. And then once again, we are going to be working with embeddings. However, we are not going to be doing a curl request from here. We are going to simply feed in our API token in order for LangChain to do its thing instead. So just go ahead and navigate to your username, view your API keys, create a new one. So this time I'm just going to call it demo, copy this key, okay, and keep it somewhere safe. And then let's go back to DataStax once more. Okay, so great. We have done everything that is to be done here. Now let's create a Python script using LangChain and Castor.io. So I'm just going to go ahead and get up my terminal once more and navigate to a directory where I want to store this. This time I'm going to store it in another directory, which is going to be WebStorm projects. And I'm going to create a directory. I'm going to call it search Python. So I'm going to use the mkdir command. And then I'm going to go into that project. So using the cd command, I'm just going into search Python or whatever you called your project. And then I'm just going to open it up using code dot, which is the shortcut to opening this up in VS Code. And great. So once we are in VS Code, I'm just going to make sure that this is enabled for Python. So in order to work with Python files, let's just go ahead and create a Python file first. I'm going to call it index.py, giving it the py extension so that our code editor knows to treat this as a Python file. Next, I'm just going to go here and click on the prompt. This has prompted me. It's saying that, it's recognizing we're working with Python and it's asking us to install the recommended Python extension. So I'm just going to go ahead and install that. And that is installing for me right now. Great. Once we have done that, we are also prompted with a little checklist. So I'm going to go ahead and just run through this. It's telling me to create a Python file, which we've already done. So the next thing we're going to do is actually add a Python environment. So let's go ahead and do that. I'm just going to go with the first one. So great, once we have made our environment, we can essentially do stuff like this. So I'm going to write print hello. So just go ahead and do the same as me. This is a Python script, a very simple one. And now if we run this by essentially pressing this little plus sign right here, that will run the script and you will see hello being printed in our terminal. Okay, so that's really it. Everything's now ready to go. We've been set up correctly. Great. So now let's get to the meatier stuff. Now, in order to install packages, you can't write it in the script here. Okay, if I go ahead and write pip install and all the Python packages that we need and hit plus, that will not work. We need to do this in the terminal. So just go ahead and paste that in like so. Just copy it out and hit enter, and that will do its thing and install all the packages that we need. The packages, once again, are Cas.io, Datasets, LangChain, OpenAI, and Tick Token. So go ahead and wait for that to do its thing. It will take some time, and once it's ready, we should be able to continue with our tutorial. Great. Now, I'm just going to go ahead and rename this file for readability, okay? I'm going to rename this to mini.qa. You'll see there's another directory above me that has been generated with everything that we've done. So just go ahead and rename your file. If you want to continue having everything the same as me, you don't have to though. That is completely up to you. Great. The next thing I'm going to do is just ask you to copy this code. So here are some variables that we're going to need in order to continue with this tutorial. So we have the AstraDB secure bundle path. We've already downloaded this onto our computers. So that is something that we're going to have to point to. And the next thing we're going to have is our AstraDB application token, as well as our AstraDB client ID. Okay, so these are things we're going to fill out from the stuff that we saw earlier from our secret things that we downloaded. Some other things that we're going to have to add are our AstraDB key space name, as well as our OpenAI API key, which we just recently saved as well. And the final thing of our AstraDB client secret too. So now let's go ahead and fill all these out. The OpenAI API key should be easy. It starts with SK like so. We previously saw this under our API keys on OpenAI. Next, I'm going to just put my AstraDB key space name, which we also did together. I named the key space name search. So if you did the same as me, just go ahead and write the string search there too. Of course, this is all very down to you. If you're copying along with me, please feel free to copy these as they are. Apart from the OpenAI API key, that will be unique to you. It should start with SK. And if you try use mine will now be deactivated or revoked, as I showed you how to do earlier as well. Next, we're going to have our AstraDB client secret. So again, this will be unique to you. Here is mine. If you try use mine, it will not work for you, but I'm pasting in here like so you can kind of see the format that yours should look like as well. Next, we're going to have our AstraDB client ID, which again will be unique to you, but it should be kind of similar in length and kind of similar in terms of the characters that are used. And once again, we have our token, which again is unique. It should start with Astra CS like so. So make sure yours does too, but the characters after it will be unique to you. And finally, we have the path to our secure bundle. So for this, just go ahead and go to your downloads and find the zip file, okay, that we downloaded when it came to downloading our secure bundle, and just drag it into the project. And once that's dragged into the project, I'm going to ask you to get the path to it, okay? So get the path like I am here and paste it in like so. As mine's in my project now, you will see the path to it in my project, which is stored in WebStorm project in the project called Search Python. So that's all I've done. Make sure it is still a zip file, so it will have the .zip extension at the end. And great. So we are now done with all those variables. Let's continue. Next, we're going to have to get some stuff from the LangChain package that we installed. So here's all the things that we're going to have to get from LangChain. So just paste that out like so. We're going to be getting Cassandra from there. We're going to be getting vector store index wrapper. We're going to be also getting the OpenAI. We're also going to be importing OpenAI as the large language model, and also importing OpenAI embeddings from LangChain embeddings. Great. As well as using the LangChain package that we installed, we're also going to get stuff from Cassandra. So what are we going to be getting from Cassandra? Well, we're going to be importing the cluster and the plain text auth provider. And finally, from datasets, we're going to import the load dataset from the package datasets that we imported earlier. Great. Now, we are going to essentially have to write some configuration in order for us to connect to DataStax Astra and create an Astra session. And to do this, we are going to create a cluster. So using the cluster import, I'm just going to pass through two things. I'm going to pass through the secure connect bundle, which we can pass through as the variable we defined above. So that is going to be passed through. And another thing we're going to have to pass through is an auth provider. Okay, and to create an auth provider, we're going to use the plain text auth provider that we imported from Cassandra and pass through our AstraDB client ID and AstraDB client secret. So this is essentially just configuration, like I said, in order to be able to communicate with our database that we created using DataStax Astra. Okay? So again, we're just using all these variables and passing them through in order to connect this to our Astra database. Great. So once we've done that, we have essentially created an Astra session that we're going to be using later. Now we're going to have to essentially connect to OpenAI using our OpenAI API key. So we're going to get the OpenAI import and just pass through our API key like so. So we're getting the variable that we defined above and passing it through and saving it under the variable LLM. The next thing we're going to do is do the same for using the OpenAI embedding. So once again, we're just passing through our OpenAI API key and we're storing all of this under the variable myEmbedding. Great. Next, we're going to essentially create a table. So we're going to actually name our table in here. We are going to pass through our AstraDB key space, which we know is the string search. And we are now going to create a table. And we're going to do that. My table is going to be called QA mini demo. So I'm passing through that string that is being created and being saved under the key space name of search in my Cassandra database. Great. So let's just check this is working. I'm just going to print loading data from Hugging Face. And then I'm actually going to get some data from Hugging Face. Okay, this is just one that exists on the internet. It's going to be some onion news. So I'm just going to load that data set from Hugging Face. And I'm just going to pass that through. And I'm going to save it as my data set. And then I'm going to get that data and I'm going to just get the headlines. And in order to check that has worked, first off, I'm just going to print some text. Okay, so I'm just going to print some text, generating embeddings and storing in AstraDB. And then I'm going to add those headlines to my Cassandra store. So I'm essentially passing that through to my database, to my AstraDB database, which is the Cassandra database. And then once that is done, I'm going to print those headlines. So let's run that code. Okay, that's all I've done. I'm just printing stuff out to appear in our console log so we can kind of have visibility about what's going on in the backend. So once that's done doing its thing, we should get that being printed. So we're going to print that text loading data from Hugging Face. So we can kind of see where we are in the script essentially. Then we're just going to print generating embeddings and storing in AstraDB. And then it's going to tell us exactly the amount of headlines that we've inserted into AstraDB. It's going to be 50 headlines. Great. That is looking wonderful. So we can now continue. Now I'm just going to essentially pass my store, my Cassandra store, into the vector store index wrapper and save it under vector index. And now I'm going to paste in some code. It's going to prompt us to enter a question. And once we have entered that question, it's going to do an if-else statement in order to print out the question and then the answer, as well as the documents by relevance. So essentially, we are going to write some text. It's going to search the Hugging Face data, so the onion news, in order to bring back any similar text. It's going to do a vector search on our database to find similar text to it based on the vector search. So let's go ahead and do that. That is the code for doing so. Please copy it. And once we have finished copying it, just run the script and you'll be prompted to enter a question. So now we can enter a question. Let's go ahead and paste one. That is, what are the biggest questions in science? The answer is, I don't know. So not a great answer really, but it's going to return some documents by relevance in our database. So you will have here the relevant document along with a temperature to show you how relevant that document is. We have biologists torture amoeba for information on where life comes from. So that's kind of similar to the question that we propose. And then we also have study shows humans still have genes to grow full coat of something. So essentially we are getting documents by relevance that exist in our database based on the question that we asked. Let's try another one. So I'm just going to ask another question. I'm going to ask, what should I know about Silicon Valley banks? Again, it says, I'm sorry, I don't know. But then it returns some documents by relevance. Again, we get a similarity score. And then we also get the document that is most relevant to the question. I'm going to ask one more. Let's ask one about amoebas because I saw it being returned in the first document. So are amoebas really our overlords? And then the answer is no, amoebas are not our overlords. And again, it returns documents by relevance. So we see that same document being returned with a similarity score that is higher based on the question. We can see that should be higher because we do have the word amoebas in there. So there is no surprise that that document is coming back with a higher similarity score. And then we also have some other documents being returned back with a lower similarity score. So great, we have managed to build an AI assistant that will essentially look in a database, look for similar documents based on our question. And if we want to have a look at what this database looks like under the hood, so essentially it's been vectorized, right? We have vectorized all the documents and then we are doing a vector search on it to bring back similar vectors to us. That is exactly what we discussed in the beginning of this tutorial. I hope you can now see how vector search works behind the hood as well as on the front end too.